All right, here are solutions for perfect problem 4 from Math 111. Bunch of function composition is how this thing starts out. So first I'm asked to figure out f of h of x, which I prefer to write like this. I think it makes it a little bit more obvious about what you have to do. And essentially what you do is you start by replacing the innermost function. So in this case, I have an h of x on the inside. And I know h of x is x minus 1. That's what it says up here. So really all I'm trying to figure out is what is f of x minus 1. Well, I know what f of x is x squared, so I can figure out x minus 1 if I just kind of picture this as a machine, and instead of putting x's in here, I put in x minus 1. So everywhere I see an x up here, I replace it with an x minus 1, and I end up with x minus 1 squared. F of, I guess I should label these. For B, there's a couple options on how you do it. I mean, essentially what it's asking you to figure out is what is f of h of g of x. So you could work from kind of the outside in. You could say f of h of x is this thing right here. So f of h of g of x is just whatever f of h of, I know g of x is 1/2 x. So I guess what I'm saying is there's a few different ways you can do this, but probably the most clever way would be to look up in part A and figure out that we already know f of h of x. This thing right here. So what I got to do is rewrite this thing right here, except everywhere I see the letter x, I got to replace it with what's inside the parentheses here. So what that would give me would be 1/2 x minus 1 for this one, and then squared for that. All right, moving on. Part C says g of all that mess. G of f of h of g of x. What am I doing on parentheses there? 1, 2, one more, I think. Whatever. Figuring out this one, you could do it a few ways. You can kind of go step by step, or you could recognize that what I'm being asked is g of something, and that something is exactly what I figured out in part B. Right? F of h of g of x was my answer to part B. So I know it's g of that thing. So what I got to do is take g of x up here and rewrite it, except everywhere I see the letter x, I replace it by all this stuff inside the parentheses. So I get 1/2, and then instead of times x, I say times 1/2 x minus 1 squared, the stuff inside the parentheses. And then finally for part D, you're asked to figure out a bunch of stuff, but really it's just h of part C, h of g of f of h of g of x. It's kind of a guess on the parentheses, it's close enough. So really I'm being asked to figure out something h of this guy. Well, this guy is 1/2 x minus 1 squared. So I can figure out h of anything. I mean, I'm given h of x up here. So to figure out h of anything, just replace the x with whatever the anything is. So in this case, it's, instead of x minus 1, 1/2 times 1/2 x minus 1 squared minus 1. So these are all the different functions. See, I could probably draw some arrows somewhere to make this easier. Sure, maybe in a different color. Yeah, I guess it doesn't matter. This stuff here ends up going inside here. And all this stuff here ends up going inside here. Maybe that helps people track stuff a little bit. But whatever, do it however you want. Those end up being the 4 answers when you compose these things together. So then what I do in part 2 here is I say that answer to part D that you just got, this thing, this, maybe I'll bring it down here, 1/2 times 1/2 x minus 1 squared minus 1. I think I copied that right. Graph that thing. Okay. Fortunately, it gives me a little hint. It says start with f of x equals x squared. Can do that. F of x equals x squared. Well, I know that 0 squared is 0, 1 squared is 1, and 2 squared is 4. And similarly, negative 1 squared is 1, and negative 2 squared is 4. So I get this graph that looks something like this. It's hard to draw on a computer. It's called a parabola. It's a U-shaped graph. It's actually not bad. I start out with this graph in red, but I don't want this graph in red. I want some other graph, namely this one. So what I got to do is apply a bunch of transformations. I got 5 points here, kind of figure out where those points go. Okay, so the order you do those things, doesn't matter whether you do your vertical transformations first or your horizontal transformations first. But what is important is that you apply your vertical transformations in the correct order and you apply your horizontal transformations in the correct order. So what I'm saying is I got 2 vertical transformations. I'll label them V1 and V2. They correspond with this 1/2 times everything and this -1 from everything. And then I also have 2 horizontal transformations. I got this 1/2 times the x and this -1. I'm going to call the -1 H1 and the 1/2 H2 to remind myself that I got to apply V1 before V2 and H1 before H2. As far as applying the H's before the V's or the V's before the H's, it makes no difference at all. So I'm going to apply the, what am I going to do? I'm going to apply the H's because those are a little bit harder. This -1 right here. The first thing to know is these are both horizontal transformations, so they're only going to change the x coordinate, not the y coordinate. All these dots here are only going to move left and right. So what does this -1 do? You might assume that it moves it to the left by 1, but it actually doesn't. It moves all points to the right by 1. The easiest way to remember that is all the horizontal stuff is kind of backwards, including the fact that I apply something, the subtraction before multiplication. That kind of goes against my order of operations. But anyways, this -1 right here is going to take this point and move it to right here. And it's going to take this point and move it to right here. This point, move it here. This point, move it here. And this point, and move it here. I could connect those. Sure, I'll connect them. Why not? I'm going to do it with a dotted line to really signify that this is just one step in a very long process. So there you go. That's what I get after I apply H1. H2, 1/2 x. So now what I'm going to do is I'm going to take all the old x coordinates, and you might expect me to multiply them by 1/2, but I'm not. I'm going to divide by 1/2. Again, horizontal stuff's kind of the opposite of what you might think, is one way to remember it. So dividing by 1/2 is the same as multiplying by 2. So if I take this point that used to be at -1 and I multiply it by 2, it's going to end up out here at -2. This point used to be at 0. 0 times 2 is 0. This point used to be at 1. 1 times 2 is 2. This point used to be at 2. 2 times 2 is 4. This point used to be at 3. 3 times 2 is 6. Sure, why not? Somewhere out there. So what I now have is a graph that looks something like this. Something like being the operative phrase because I'm not very good at drawing these things. But fine, so you got to remember this is step 1. This is step 2. And I'm not done. I still got to apply my vertical transformations. So I got 2 left. I have this vertical transformation and this vertical transformation. I think it's time to break out a new color here. So let's see, maybe I'll go to purple. Okay, so I want to apply V1 before V2 because it makes sense to do multiplication before addition and subtraction if you think of order of operations. But you're like, wait a minute, you just did addition and subtraction before multiplication earlier. Right, because those were horizontal. Horizontal, everything's backwards. At least that's how I remember it. So I'm going to apply this transformation, this 1/2. I'm going to take all the old y coordinates, I'm going to multiply them by 1/2. Wait, over here you divided by 1/2 instead of multiplying by 1/2. Right, you'd expect to multiply by 1/2 because this 1/2 is getting multiplied by stuff, but horizontal is backwards, so I end up dividing by 1/2. But here it's vertical, so I'm going to multiply by 1/2. I'm going to take all of the y coordinates here, 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 and here, and multiply them by 1/2. So this y coordinate used to be 4, it's now 2. This y coordinate right here used to be 1, so now it's 1/2. This y coordinate used to be 0. 0 times 1/2 is 0. 1 times 1/2 again is 1/2. And this guy here that was at 4 is now down here at 2. And I get another dotted line. Try my best to connect these purple dots. It's going to be unfortunate when I print it out in black and white and hand it to people for solutions because they're all going to look the same. But whatever. Okay, one more step. My last vertical transformation, this -1 right here. I'm going to subtract 1 from all of the y coordinates. I know that I added 1 to all the x coordinates over here, but again, that's because these were horizontal, so they're backwards. You see the -1, and you actually add 1 in here. Here you see a -1, and you subtract 1, just like you would expect to, because it's vertical, and vertical works out the way it should. So this point right here has a y coordinate of 2. 2 minus 1 is 1. This point right here has a y coordinate of 1/2. 1/2 minus 1 is -1/2. This point right here has a y coordinate of 0. 0 minus 1, -1. Again, -1/2 and 1. And so now what I got to do is, this is my final graph, so I'm not going to do it dotted. I'm going to try my best to connect them with the nice little curve. Meh, not too bad. Whatever, something like that. And I'll even write final answer is this guy. Whatever. So there you go. There's your final answer. It's a graph of this mess, h of g of f of h of g of x. In other words, this function right here. And we got there not by plugging in any values into this mess, but instead by starting with something that we know and recognizing that this is a lot like this. It's just what you get if you apply 4 different transformations, which we applied here. So I guess that's the end of this. I'll stop this video here.